Welcome to MSc videos. It's time to learn. So in this video lecture we are going to discuss about 2D viewing. So till now we discussed about how to draw 2D objects and how to perform transformation on those 2D objects. Now how to display those 2D objects in a display device. For that we are going to discuss about 2D viewing. What is 2D viewing? To define this viewing, we are going to define two important coordinates. First one is window and second one is a viewport. Simply window is defined as what is to be viewed and viewport is defined as where is to be displayed. If you are drawing any 2D object, we want to display some portion of that particular image to be viewed to the user. That's what we are saying as a window. And the particular selected portion may be displayed anywhere else. That's what we are saying as a viewport. World coordinate area selected for display is defined as a window. Simply we are calling it as what is to be viewed. And viewport, an area on a display device to which a window is mapped. The same window is mapped in a viewport. That's what we are saying as a where is to be displayed. Here we are saying the first picture indicating a window. A window contains some images, and then on that, by using a world coordinates, we are specifically selecting some portion of the. Here is the original image. By using the world coordinate xw minimum to xw maximum and yw minimum and yw maximum, we are selecting this portion. The same portion is displayed in a viewport by using the coordinate xv minimum, xv maximum and yv minimum and then yv maximum. How we are going to convert this? We are having a original image in this world coordinate. We are going to convert what are all the parts which are all available inside this window. The same part must be displayed in the viewport also. It is not necessary that window size must be equivalent to the viewport size. It may be of different size. Either window size may be higher than the viewport size or viewport size may be higher than the window size. But the location of the parts which are all present in the window must be same as that of the location of the particular objects which are all present in the viewport. I am once again saying the location must be same, not the values. Let us consider if a point is located at 50, 50 in the window of size 0 to 100, which means that exactly the point is presented at half of the window. 0 to 100, here also 0 to 100, and here we are having a point which is located at 50, 50, which means that the point is exactly located at half of the window. If you want to convert this window into a viewport, let us consider the viewport may be present of the size 0 to 50. Here also 0 to 50. Now it must be, the point must be present here at 25, 25, which is actually half of the viewport. So this transformation must be same. The location must be same in the window as well as viewport, not the values. Here we are having a point which is located at xw, yw. Now it is transferred to xv, yv. It's a location inside the window. It is location inside the viewport. So by using a formula, we are going to identify the new location value inside the viewport. Now we are going to identify the scaling value further. Now the size of the window is xw minimum to xw maximum and yw minimum to yw maximum, and the size may be increased or decreased. So here it is converted into xp minimum to xv maximum and yv minimum to yv maximum. So the scaling factor we are going to consider it as xv max minus xv minimum divided by xw max minus xw minimum. If the size is increased means then we are having a positive, that is greater than 1. If the size is minimum means size is reduced means the scaling factor value may be less than 1. And similarly we are going to use it for scaling factor for y. And how we are going to identify the new location of the point xv, yv by using this formula. So xv minus xv minimum divided by xv maximum minus xv minimum, which is equivalent to xw minus xw minimum divided by xw maximum minus xw minimum. So which is means that the location of this particular point, which is same as that of the location of in the viewport, the same value must be represented. So here also we will use the same point for a y axis also. So you can substitute this, you can cross, we want to identify this xv as well as yv, so we will cross multiply here. So we will perform the cross multiplication. So xv equal to xv minus xv minimum equal to this formula. So this term and this term forms a scaling factor. So we will substitute the first equation, so it forms a scaling factor sx, and you transfer this xv minimum to that right hand side. So now xv equal to xv minimum plus xw minus xw minimum into sx, and similarly you will get a yv also. So this is a formula to identify the new location value of the point. Now let us discuss an example for this conversion. Let us consider a window is located from 0 to 100. So the size of the window is 100, and a point is located at 30, 30. Identify the point, new location, the viewport. Consider the viewport size is 0 to 50. So window is 0 to 100 and viewport is 0 to 50. So we will know that the viewport size is reduced. So let us we will identify the terms which are all present. xw minimum is 0, xw maximum is 100, yw minimum is 0, yw maximum is 100, and viewport size is also given. xv minimum equal to 0, xv maximum equal to 50, and similarly y minimum equal to 0 and yv minimum maximum equal to 50. A point is located at 30, 30, and here we are having, this is in the window. So this is actually the window. A point is located at 30, 30. Actually the 30th percentage of this window. So this 30th percentage must be same in the viewport also. So let us substitute the formula. So here we are having, we know the formula for this, what is sx. So window size is 100, viewport size is 50, so halfly it is reduced. So scaling factor in x axis is 1 by 2, scaling factor in y axis is also 1 by 2. So we will identify xv. So xv equal to, we are substituting the formula, we are getting the value as 50, and yv also 50. So now we are identifying a new point. Here you see, now the same point which is located in 30, 30 with the window size 0, 100, now it is transferred to 50, 50 with the viewport is 0, 50. So which is the same conversion. The location is same but the values are different. This is how we are going to convert every 2D object from window into a viewport. So the next class we will discuss about how to perform this clipping operation. Thank you for watching. Keep on visiting my channel. Thank you.